Okay, so now we're in section 5.2. In 5.2, we're going to look at values and having to standardize them so that we can use the standard normal table. All right, so if a random variable x is normally distributed, we can standardize the x, then find the value using the standard normal table. If we're looking for the probability that x is less than 600, recall I told you a little while ago that the probability that x is less than 600 is equivalent to the cumulative area. Less than is equivalent to finding the area shaded to the left. The mean is 500 and the standard deviation is 100. So we standardize that score using value 600 minus mean 500 divided by 100 is 1. So finding the probability that x is less than 600 is equivalent to finding the probability that z is less than 1. We can use the standard normal table to find this value. Sorry. And so these two areas would be equivalent to each other. Now let's look at another example. Here we have a survey that says that a shopper spends an average of 45 minutes in the supermarket with a standard deviation of 12. We want to find the probability that a shopper will be in the store between 24 and 54 minutes. So the first thing we need to do is let's graph this on an x, the normal curve, on the x-axis. Remember the mean was 45 and we're looking for between 54 and 24. So we're looking for this area shaded in blue. We need to standardize both of those scores. One of them is value minus mean divided by standard deviation is negative 1.75. That corresponds to an x being 24. And value minus mean divided by standard deviation 0.75, that corresponds to a value of x being 54. We can look up these two values on the standard normal table. Recall we look up this value, then in this value we take the value found in the table with this, minus that, and we get 0.7734 minus 0.0401, or approximately 0.7333. So the probability that a randomly selected shopper will be in the store between 24 and 54 minutes is about 73% probability. Let's do another example. Let's find the probability that the shopper will be in the store for more than 39 minutes. Okay, more than 39 minutes corresponds to on the standard normal distribution of probability that z is greater than negative 0.50, value minus mean divided by standard deviation. We look up this value in the standard normal table. We get 0.3085. But that's not our answer because we're looking for the area shaded to the right. So it's 1 minus 0.3085, or about 69%. Now, if 200 shoppers entered the store, we would expect about 69% of them to stay in the store longer than 39 minutes. So 200 times 0.6915 is equal to 138.3, or about 138 shoppers would be in the store for more than 39 minutes. Now, we don't use technology in this class because I would have had to make everyone required to purchase either a TI-83 or some kind of statistical software. But I just want you to be aware that you can use things like statistical software like Minitab, or Excel has some of the more basic statistical software in it, or the TI-83 does also. I'm not going to go into this because we're not using technology in this class. We're going to use the standard normal tables. That's the end of section 5.2. You can now go to the Course Compass website and complete the homework assignment for section 5.2.